Hey, what's up, everybody? Hopefully, you guys have been enjoying the series I've been doing on why Asset Framework is so critical to your operations. And this is the third part of the series. Next week, I'm going to do multivariate data analysis with a tool outside of the Pi system. I'm going to show you how we use some AF and event frames data to help us with an analysis there. But today, I want to talk about several subjects. For those of you that are management or operations types that you might gloss over a little bit on this. I hope you don't, because there's some important things you need to learn and understand. What I'm going to do is talk today about the role of Pi, of asset framework, of event frames in advanced analytics like machine learning, multivariate data analysis, and even into AI. Like, why is it even important that I get all of the underlying data right? I have all my data in Pi, right? Everything should be great, right? I can just dump it in a data warehouse and have a data scientist come tell me what's wrong with my plant or my operations, right? It doesn't really work that way, especially in a time series environment in an industrial plant. There's lots of reasons why, and I'll expound on some of them today. So the first thing I want to talk about is there was a thread on LinkedIn. I posted an article that John Marriott of OSIsoft, he's our partner manager, he posted an article that had been written about the Pi system and how it can play a role in a data warehouse application, and how sometimes doing some aggregations at the Pi system level and then piping that into the data warehouse is probably a whole lot more valuable than just pumping raw data in there with no context around it. So AF allows you to add the context to the data. Like if you have a temperature, you can say if it's in degrees Fahrenheit or degrees Celsius. You can say what it is, because you think about it, 70 degrees, probably a good thing for any temperature outside in February. Probably not a good thing if it's the temperature of my refrigerator right now, right? So just having that context really helps you. So there was a fellow by the name of, and if I mispronounce your name, I'm really sorry, but Vijay Kumar. He actually commented on my thread. He actually made some really good points that you need to be really careful of, and we kind of went back and forth. You almost might say we kind of argued, but I think we were actually on the same side. But he was making a point and I was making a point that I think both of us actually agree with each other. And we actually have an appointment. We're going to actually talk here in a few weeks about this. But I'm going to read what he said on this thread, because I agreed with the article's assessment. I think you need to do some summary. So what he said was, the first rule of any discrete sampling is to make sure you retain the data at its native sampling frequency, even if in a cold storage archive. I would be extremely wary in applying predefined filters for getting rid of redundancy, as he quoted, especially in the current age when storage backup archivals are cheap to implement and execute. There are infinite possible ways for one to transform, post-process, aggregate, or combine various time series, whether regular or irregular, like you would see in a Pi system. However, none of those processing pathways should have a prerequisite of removing any shape, form of redundancy. I have nothing against any data retrieval or transformation platform or system, but I am never in favor of breaking my fundamental tenets of data governance. And I agree with you. I absolutely agree. I think I don't necessarily always see everything as redundant. And one of the points I made back to him was that my point is sometimes the Pi system has dirty data, and raw data is a very weird term to me, because I'm going to show you an example here in just a minute where I'm going to show you a couple of examples where the raw data may or may not be within the instrument's range of good. I might look at, matter of fact, let's just switch over and we'll take a look at it. So this is a temperature sensor right here that we're looking at. And as you can see, this is going anywhere between about 462 degrees or so up to about 468. Now, my experience tells me that temperature sensor is probably good to about plus or minus a degree, depending on whether it's RTD, thermocouple, whatever. So I suspect, and this is a snapshot. This is actually raw data coming into Pi, funneling into Pi Vision. This is not the actual archive data. And so one could make the argument that this is the raw data. My argument against that would be there's a lot of movement between, say, 465 and 466 that may or may not even be accurate. It may be just instrument noise. And I think, that is something that we kind of have to think about when we're storing data, is what's real and what's not. Now, in this particular case, I'm going to show you what's actually getting stored in the archive. In the last 3 hours, they've stored 3 values. 3. That's it. My suspicion is this data is probably over compressed. We're probably not getting enough information out of this signal. So I see this a lot, and almost as bad, I see people turn compression completely off and they get every value. I don't think either scenario is good. I think you have to do proper compression tuning to make that work, and we have a partner that helps us do that. That's Pattern Discovery with Compression Insight, and I've written an article on that. I'll link it in the description if you're watching on YouTube, or in my LinkedIn feed. So I think raw data is a really, a term you have to define. Okay, so with that said, let's go back to an example that I blogged about in the summer, maybe late fall, where we had a problem where we felt like we had a failure with machine learning. And I want to kind of go through this scenario because there's actually some things we had to do to the data with the Pi Analytics engine that would have helped us on the machine learning model. So this was a Tableau investigation that I had done because I was getting frustrated that I wasn't finding anything in the machine learning algorithms. And I just started doing a bunch of comparisons. So to kind of set this up, I can't give too much away because I don't want to tell you, who this is or what kind of process this is, and it doesn't even matter. But what we were looking for is on this top signal, we see this big spike in it. That was a lab measurement confirming that there was a problem. Okay, it was a contamination problem. What we'd see is we would see a temperature spike, we would see a drop in another signal, we would see a spike in another, a spike in another, and a drop in another. All happen within about a 15-minute window. And that could be anywhere between about 2.5 hours before this spike and maybe even as much as a day. And so really what we need to do with the machine learning algorithm is almost like what we're doing with Tableau here, is put that red filter on it and scroll that across all the data and look for that pattern. I'm not sure we were using the right tools to do that. I think there are tools out there that will actually help us do that. And I actually have an appointment with a PhD level data scientist who teaches this stuff. We're going to go over this example and like, what did I miss? And so I think he's going to shed a lot of light on that for me. So that's a little bit about the problem. And let me make sure that I'm getting all my notes here. So some of the things that on this, we really had to do some data conditioning on some of these signals, because sometimes this temperature, this second signal here, sometimes it might go from 1250 to 1280. The next time it may go from 1280 to 1550. The next time it would go from 1280 to say 1330. It would never change by the exact same amount. It would change to varying degrees. The second signal, it would have to have a certain drop. You see that kind of V-shaped pattern? That's what we needed to really look for. It would drop down, and literally this is a change from about 3.11 to about 3.08, give or take. Okay, but I mean, we're talking a couple of hundredths of a point on this signal. Now, this particular instrument is accurate enough down to that range, and they actually were over compressing this at first, and then they decided they needed to get the compression set right, which allows us to actually see this little phenomena happen. But the raw data really didn't help us. We were trying to do some stuff on the raw data, and that really wasn't the issue. This wasn't an absolute problem. This was a relative problem. So I'm going to show you kind of what we did. And I'm going to show you some cool little tricks while we're at it, of things you can do in the Pi system and with BI tools and things of that nature. So what we ended up doing, this is the final result. What the operator can look at now is they can see a percentage chance of what we think this problem is going to happen, this contamination issue. And here's that raw signal of the fluid signal that we were looking at, that moves from 3.11 to 3.09. I mean, I'm sorry, 3.08. Literally, this scale is from 3.1 to 3.13. So you see it doesn't move much. Even though it looks very noisy, it's really not moving that much. This is the temperature signal. This is the lab signal, and these are those other three signals that all kind of moved around. And then there's a couple other things we found that we kind of need to tell the operator on. But what we did was we rolled it up. We used Pi Analytics. So a little discussion about how we did some of this was I took a 5-minute average of this fluid signal. Because when I could take a 5-minute average and compare that to an hourly maximum, I could say how much did it drop. I'm looking for that V-shaped pattern. I'm looking for a percent change and an absolute change. If I saw those two things, I know there was probably a potential contamination issue. We also looked at this temperature as well, and I want to say we took an hourly average or maybe like a 10-minute average or something. But we actually had to do some aggregation of the data to give to the operator to show them, hey, here's what's going on in your operation. That also would probably be the right data to feed the machine learning model. So I don't know that that's redundancy. There are cases I agree with VGiant on that because there could be some redundancy. In this particular case, being that we couldn't find a machine learning agent to sit here and run this, which I think is the future state of what we're going to do here, we're probably not going to leave this long term in a Pi Analytics space. I think what we're going to need to do is put a machine learning agent, on looking at this pattern and figuring it out for us. So I still kind of consider this a machine learning failure, but we did get a success out of it, and we were actually able to use the tools that we have, with Pi Analytics. So the other thing that we were able to do is because we could get this pattern, I could say, tell me every time this percentage gets over, say 80%. So then what I could do is I could actually look at an Excel report, because I could backfill those events and say, tell me every time that's happened since January 1st of 2017, which is when they put one of these instruments in play. Now all of a sudden I have a whole list of events. I have when they started, when they ended, how long they lasted, and then it's just simply a matter of clicking trend for this event, and I get that exact same screen I just had with that event on it. And in my case, I chose to look at, I think, 2 hours after the event and 8 hours before or something like that. I can't remember exactly what I had configured, but you see, here there's a lab sample. You see it spike, so that was the confirmation of the event. We see almost 100%, of the event. Dang it, come here. There we go. So we're gonna rewind it to see what the operator would have been looking at. So let's look at 8 hours back. So you can see the V-shaped pattern. You can see the spike in the temperature. You can see these signals kind of do their number. This one drops, this one rises, and this is a ratio between those, and it rises. So we can see that this is what the operator would have been looking at. Hey, I know I need to take action. There's this big red box that tells me there's a really high probability of a problem. But if we hadn't been able to do some of the analytics and the event frames, we really wouldn't have been able to go through and validate all of our work. Actually, we found, because I had that Excel report and could click through like that, the subject matter expert for the plant and I walked through this and said, okay, here are some other things that are going on in the plant that we probably need to filter out. So we were actually able to do a lot of really great validation here. The other thing, through the Pi Integrator for Business Analytics, we were also able to take a 1-minute snapshot of each event and do comparisons. So right now I have kind of a classic event, up on the screen. If I want to compare it to another one, I can just hold down Control and start clicking some of these other events and do comparisons and say, do they look the same? So you think about this could be done for batch comparison, this could be done for environmental excursions, it could be done for any kind of events, downtime events, whatever. Do I see the same pattern? So this is kind of maybe a first pass of subject matter expert being able to look at all the events and see if they see a pattern. Also could be a way that we are able to take that data and slice it up and say, hey, machine learning model, here's what happened immediately before and during the event. Here's all the data. Now compare it to data of when things are running good and I don't have a problem. So I really think, having asset framework and event frames to, in our case, we did some analytics. That's a term I learned last week. We did some manual analytics really with the Pi system, not necessarily in Excel, which is kind of what he was referring to, but we did some, in the Pi system that at least are running in the background, but that was a lot of manual work. This right here is probably going to be a lot of manual work. But right now it's the best we got. It's better than anything else we had done, and it's a heck of a lot better than going back through process book screen after process book screen, scrolling back through time trying to find things. At least we can zoom in on the things we want. So to me, if you sum all of this up, you have to get the data right, the compression right, so that your data is accurate. I think there are those times when it's not redundant to do aggregation, cleanup, filtering, things like that at the Pi system level or whatever. This is edge analytics, okay, if we want to use a buzzword. The Pi system here is on the edge analytics. So I don't think that's ever a bad thing. And here's the analogy I always use. If I have a car, okay, and it's self-driving and it sees an object in the road, I do not want it to go up to the cloud, make a decision based on some algorithm running in the cloud to figure out whether or not I need to dodge this or it needs to dodge this object in the road. I want it to make that decision on board. That's edge analytics. Now, I drive a Toyota Tundra. I would like to pipe some of my data to the cloud, and if there is a problem with all the Tundras in the world, and because they have all the data and they're monitoring it, and they say, oh, you have a problem with your Tundra because we know all of the Tundras in the world have the same problem, I would want to know about that. Cloud analytics, big data, right? So I think, the Pi system and other edge type devices like this or systems, doing analytics and aggregation to show an operator at the edge level, I don't think that's redundant at all. Sometimes it is. I think to Vijayant's part, it is. But I think sometimes it's not. And so I wanted to make that point. And really, I think with some of the analytic stuff you can do, you can really give operators a lot better. With this example and the one last week, you can give operators a lot more insight into their operation sometimes. And also it can feed these advanced analytics models. So hopefully that kind of wraps up, that whole concept. Quickly. But sorry, let's see, I'm at 17, almost 18 minutes here, so I'm going to go ahead and cut this thing off. But anyway, hope that helps you with some ideas and thoughts in your own company.